What is entanglement theory? It is a mystery, and here is a potential solution, but its implications are so paradigm-shattering that most scientists refuse to believe it. Maybe we can't handle the truth? Consider the scenario where an extraordinary pair of dice is discovered, possessing the unique characteristic of always yielding a combined sum of 7, regardless of the manner in which they are thrown. This remarkable phenomenon is known as entanglement, wherein the fate of one die remains uncertain until observed, yet the moment it reveals a number, the other die instantaneously aligns itself to ensure their combined total always reaches 7. Astonishingly, this entangled pair of dice can be separated, enabling one to be entrusted to a companion in a distant location, while the other remains within the possession of the discoverer in a different locale, such as Las Vegas. Remarkably, as soon as the dice in Las Vegas are rolled, the corresponding die in the remote location promptly displays a number that mathematically tallies to 7. This instantaneous synchronization raises an intriguing question: did the dice somehow communicate across vast distances faster than the speed of light to convey this information to Macau? The concept of entanglement holds profound implications for our understanding of the universe, provoking awe and wonder. Although the example of entangled dice is merely hypothetical, the existence of entangled pairs of particles in the realm of quantum mechanics is incontrovertibly real and operates in a similar fashion. To comprehend entanglement more comprehensively, one must first acknowledge the quantum scale's inherent ambiguity, where reality remains indeterminate until measured. Analogously, a die in midair lacks a definite face until it lands, representing all possible values simultaneously. Quantum particles, such as photons, exhibit a comparable characteristic, existing in multiple states simultaneously until measured, at which point they assume a singular state. Furthermore, if these particles are entangled, the act of measuring one particle instantaneously influences its entangled counterpart, irrespective of the spatial separation between them. This notion, termed spooky action at a distance, was met with disdain by Albert Einstein, who postulated that the entangled particles carried intrinsic information about each other from the moment of entanglement when they were in close proximity. In essence, Einstein contended that the properties of both particles were predetermined locally and persisted from their initial entanglement. Conversely, the quantum world posits that such foresight is impossible, as particles lack knowledge of their specific attributes until measured, much like the dice simultaneously embodying all numbers while airborne. Einstein's perspective, founded upon the concept of predetermined entangled particles, remained resilient due to the absence of conclusive evidence to refute it. However, in 1964, an eminent Irish physicist named John Bell devised a groundbreaking experiment capable of substantiating the presence of encoded information within entangled particles, or validating the reality of spooky action at a distance. Leveraging the fundamental principle of quantum mechanics, which stipulates that measurement inherently affects the measured entity, Bell's test sought to determine whether random actions performed upon one particle would impact its distant counterpart if Einstein's hypothesis held true. The conclusive findings of this experiment incontrovertibly affirmed the accuracy of quantum mechanics, refuted Einstein's suppositions, and unequivocally established the occurrence of spooky action at a distance. Since 1964, numerous experiments have consistently validated a profound truth that Einstein himself feared. Hidden elements of reality that act locally to influence quantum measurement outcomes do not exist. Consequently, entangled particles appear to communicate instantaneously, or rather, at a rate at least 10,000 times faster than the speed of light, if any form of communication indeed occurs. However, the precise speed of this hypothetical communication is inconsequential. Even a minuscule increase in velocity beyond the speed of light would not only violate Einstein's theory of relativity, but also disrupt the very fabric of our understanding of reality. As a result, most scientists have converged upon the conclusion that faster-than-light communication remains an implausible occurrence. This prompts a rather perplexing question: if no external signal instructs these particles on how to coordinate their results, what then is transpiring? The answer lies in the perplexing nature of quantum physics, which challenges our human comprehension. At its fundamental level, reality presents itself as fuzzy, uncertain, and undetermined. Or so it seems. Yet, an alternative possibility, less favored among scientists but proposed by Bell himself, offers a potential resolution to the enigma of entanglement: superdeterminism. According to this concept, the entire universe operates under the principle of absolute determinism, devoid of any semblance of free will. In this scenario, every aspect of reality is preordained, unchangeable, and akin to a pre-existing clockwork mechanism. Our actions, decisions, and even our perception of freedom to choose are mere illusions, as everything is already predetermined. Genuine choices, such as an experimenter selecting one set of measurements over another, have no true existence. Randomness is but a mirage. If this were indeed the case, the enigma of entanglement would cease to be perplexing. Faster-than-light signals would be rendered unnecessary, as particle A would already possess knowledge of the measurement carried out on particle B. The predetermined nature of the universe would eliminate any need for communication. Could this be the essence of reality? Could Einstein's belief that God does not engage in games of chance with the universe have been correct all along? Is it possible, as some religious individuals might assert, that everything is written? Don't hesitate to subscribe to my channel to keep in touch with more education videos as I explore more questions.